Clean and develop using Python. This is the presentation from Group F. Abdulaziz, Juan Pedro, Jacob, Alexander, Esperanza, and Addison.
For this project, we have used three of the most popular Python libraries: Pandas, Matplotlib, and scikit-learn. Pandas is a Python library for data manipulation and analysis. The name of the library comes from Panel Data. The developer Wes McKinney started working on Pandas in 2008 out of the need for performing analysis on financial data. By the end of 2009, it had been open source and actively supported by a huge community. Matplotlib is a plotting library, a multi-platform data visualization tool for Python, and its numerical extension NumPy. Although it has its origins in emulating the MATLAB graphics, it is currently independent of MATLAB. It was conceived by John Hunter in 2002. The third library is scikit-learn. It is a machine learning library. It features various classification, regression, and clustering algorithms. It was initially developed by David Kornpau in 2007. Later, Matthew Brosher joined the project and started to use it as a part of his thesis work. In 2010, the French Institute for Research in Computer Science and Automation got involved, and the first public release was published in late January 2010.
Exploratory data analysis, or EDA for short.
Exploratory data analysis is an approach to analyzing datasets to summarize their main characteristics, including descriptive statistics such as measures of central tendency, dispersion, and distribution of the values and presence of outliers. Visualizations of the data can also be used to summarize both categorical or numerical values. For this dataset, which is coming from banking transactions, we look at the descriptive statistics, including the mean, the standard deviation, minimum and maximum values, the number of observations, and the number of features. We found that this dataset contains 56 columns or features and 225,013 rows or observations. We also use histograms, box plots, and multivariate plots to examine the underlying frequency distribution or shape of the data. We found that the dataset contains columns or features that contains only NA values or constant values, which will not add value to the subsequent analysis. It also contains features that contains a number of missing values, duplicated rows, or highly correlated values that are needed to be treated for subsequent analysis. All these issues were flagged during the exploratory data analysis, and as well as this histogram highlights the information that are featured in the data. This information will help us decide on the next steps for data cleaning and transformations.
Data preparation. Let's talk about data quality and how to fix.
We all know about the data scientist nightmares, which is dealing with the data quality issues. In Kaggle Survey 2019, data scientists spend more than 70% of their time in analyzing and understanding the data, including the pre-processing and cleansing stage. This picture, I think it's familiar with you. There are companies that they are investing a lot of money in the infrastructure, building data warehouse and data lakes. However, if you do not care about the data quality, all of these fancy infrastructures will be useless. Here, some of the most common data pre-processing techniques that every data scientist should know. It varies from dimensionality reduction, outliers removal, as well as finding highly correlated features. Of course, it depends on the problems that we may face on the dataset, so not all of these should be used. It is very important to know that the data pre-processing should be completed before doing any machine learning or modeling. Before we start the pre-processing stage with our dataset, we wanted to know how many missing values are there. So using pandas, we have identified that 2.1 millions of missing values exist. That is a percentage of 17 ratio of the total missing value in the dataset. Next, my friend Juan Pedro will talk in details about some of the pre-processing steps that we have done.
There is a particular case in our dataset. That's the column birthplace. This column has missing values in another way. We address this variable in a particular way, so let's check it out. Let's do a quick exploratory description of the column. Using value counts, we get the descending order so that the first element is the most frequently occurring element. It is evident that the cells that contain question marks are not valid input in our data. To fix it, we did a for loop that its limit with the .find method. Let's go step by step around this chunk of code and fix this issue. We have done a for loop for all the values inside the column birthplace. It's including a try except to solve possible problems of the function find, when it's not possible to apply. But the core of this code is to check if it's possible to find any question mark or even a zero in the cell prior removal of any white space surrounding. If we found any of the previous, we add to the out vector a hyphen. If Python is not able to find either the question mark or the zero, we just append the original value. At the end of the code, we just fully replace the original column with the out vector. And now we have a lower cardinality column, and better, we have fixed the invalid input in our dataset. Now, let's focus on the missing value replacements. When we look at our dataset, we notice there are some cells flagged as NaN. That means that those cell values are missing. We calculate more than 2 million cells that are missing. Why we have so many missing? The reason could be different. Maybe it's something we have to discuss with the client or whoever provides us the dataset. In our case, because we don't have access to that person, we have to consider possible strategies and choose the one that considers applies the best. There are multiple strategies to handle the missing values. For example, and to show a few of them, one strategy could be write a constant value in those cells, like for example a 0 or a negative value. Apply a statistical representative value to the cells, like the mean, the mode, or even the P25, whatever is most representative. Also, we can adjust or create rules for what we do, being row dependent. Another could be simply remove the rows where there's any missing value. Be careful on this one, or just rethink the problem. In our case, we choose to use statistical representative values. For example, when missing numbers, we use the mean, and for each categorical column, we impute the mode to replace the nulls. How we fix these problems? Let's do a step-by-step solution for the numerical values. This is a complete chunk of code we use in this case, but let's go line by line. First, we define a vector with the column names that are from the type integer or float, in other words, columns that are numbers. Then we go across all those columns using a for loop. What we do is check if there is any missing value in a particular column by summing the number of nulls. Just for your reference, its null returns a Boolean vector, but Python has the capability when summing a Boolean true to consider as 1. So if the result of the sum is greater than 1, we apply the following. We calculate the mean of the column, we apply the mean to the cells where any missing, we create a Boolean column to flag the missing values that are added as replacement.
Modeling. We are going to create and evaluate linear regression models.
Now we are going to use the clean and transform data to build a regression model. Linear regression is a statistical model used to predict the relationship between independent and dependent variables by examining two factors. The first important one is which variables in particular are significant predictors of the outcome variables. And the second one that we need to look at closely is how significant is the regression line to make predictions with highest possible accuracy. If it's inaccurate, then we cannot use it, so it is important we find out the most accurate line we can get. The linear regression with one dependent variable and multiple independent variables is represented by this equation, y being the dependent variable, x being the independent variables, m in this case is the slope of the line, and c is the coefficient of the line. In our case, we have RBA value as our y, or the dependent variable, and we have the rest of the 55 columns as our independent variables. As we have categorical variables in the list of our independent variables, we need to perform a one-hot encoding. Our categorical labels should be encoded so that they can take form of an integer or a vector of integers as a prerequisite when building a machine learning model. One-hot encoding transforms our categorical labels into vectors of zeros and ones. The length of this vector is equal to the number of classes or categories that our model is expected to classify. So if we are classifying whether the customer type is a 1 or a 2, then our one-hot encoded vectors that correspond to these classes would each be of length 2, since we have 2 categories in total. We are splitting the data into train and test data sets. That's an 80-20 split in our case, after which we fit a linear regression model to predict the RBA value. We are building the model using the training data. With some couple of lines here, we created the whole of the regression model, so we are able to fit the data to the linear regression model. Now we have to make sure that our model is valid and acceptable. Check if the model works and understand how good it works. So one way to do that is by calculating the R-squared value. That's what we're going to use to predict how good our prediction is. So in the R2 score, we take our y-test versus our y-predict. Y-test is the actual values we're testing. That is the one we're given to us, and so we know that it is true. The y-predict is the output of our prediction and is something that we think is true. We have a 0.95 R2 score, and we do want that in the upper 90s. Therefore, it shows that this is a very valid prediction based on R2 score. This proves that our model is a good model, which means success. We successfully train our model with certain predictors and estimate the RBA value using linear regression.
Thank you.